Okay, today we're going to solve for the missing values and sides using similar polygons. Because they're similar polygons, it's not necessary for us to check everything. We're giving that to you. That is given. Technically, the first step here is to write similarity proportion using the letters. Step number 1. For some of us, it may be easier if we write a similarity statement. So we will start there. We will call the first triangle RAT. I will go from 1 arc mark to 2 arc marks to 0 arc marks, so RAT. And that triangle is similar to triangle GPI, going from 1 arc mark to 2 arc marks to 0 arc marks. There, we have a similarity statement. Now we can use this similarity statement to easily write our similarity proportion in step 1 using our letters. I will zoom in a bit to make this a little easier. Relocate this. We have side RA, then side AT, and side RT. And we will match it up with the second side of our similarity statement, and it will be GP, PI, and GI. This will make it much easier now to match up the letters or variables going around our side. So, looking at the top of our similarity statement RA and going across to AT and RT, we will just match up the Y variable, the 3, and the 5. So it looks like we have RA is Y. We will write Y here for step 2. We have AT is 3 right here, AT. So we would put a 3 there. And then we have 5, RT right here, RT. And we'll put our 5 here. We will do the same with the second triangle, the larger triangle over here. Just follow our way around, starting off with GP, right? GP right here is 6. From 6, we'll work our way to the 9 and ultimately to the X. Now that step 2 is done, where we substituted the numbers in for the sides, relatively simple, we will follow step 3 and solve for our unknowns or our variables. So we move back over here to our large proportion, and we will simply cross multiply using the 3 and the 9 in the middle with the 3 times x and then the 9 times 5. It looks something like this. 3 times x equals 9 times 5. We will then simply continue. 3x equals 45 divided by 3, and x equals 15. We will take our 15 and we will substitute it in for our x and eventually reduce our fractions. Right now, we're going to go back up and we're going to do the same thing, but we're going to cross multiply the other direction and use our 9 times y and our 3 times 6. So let's see. We will now have 9 times y equals 3 times 6. 9 times y is 9y. 3 times 6, 18. Divide by 9. Divide by 9. 9's cancel. We have y equals 2. We'll take both of our x for 15 and our y for our 2, and we will substitute those right back in here for our y and our x, and we will rewrite this statement down here in step 4. So let's see. we have y is 2, and that would be over the 6. That equals the 3 and the 9, which also equals the 5 and the 15. We will then use our calculator to reduce these. 2 6 reduces down to 1/3. 3 9 reduces down to 1/3. And 5 15 also reduces down to 1/3. Seeing as we have 3 ratios that are the same, our similarity statement in step 4 over here, step 4 says find the similarity ratio. We have then found our similarity ratio right here. Step 4, 1/3. In example number 2, we have a trapezoid, and we're only asking you to solve for 2 sides, so we're saving a little bit of work. You're welcome. Same thing follows. We have step 1, that is write a similarity proportion using our letters, and we're going to start off by writing our similarity statement first. So we're going to go Q, U, A, D, and that is similar to, and we have to be careful and follow the same pattern here, G, O, E, M on our second trapezoid. So it looks like we went Q, U, A, D, 90 degrees, nothing, 1 arc mark, and we went G, 90 degrees, nothing over here to 1 arc mark. So we followed that same pattern on both sides. This statement will make it much easier to record our similarity proportion for step 1. I will enlarge it a little for me to make it easier to write. I will now use QU and then UA. Relocate this a little. I will then use AD and QD. Following that same pattern on the bottom, I will use GO, OE, EM, and then GM. That will allow me then to simply match up the numbers on our diagrams and continue and just substitute in. So I will now take QU right here at the top, right? UA, AD, and QD, and I will just work my way around our first trapezoid. So we have QU looks to be 5. UA, we don't have anything in this case, so we'll just leave it empty. AD also nothing, leaving it empty. And then QD is 3. Same on the bottom. I will follow all these statements, work my way around, starting with GO to OE. So GO is 3x minus 7. We do not have anything for OE or EM. And then for GM, we have x plus 3. We will then use these, not the middle. And we will use those 2 that we have to just cross multiply the same way we did in the first example. I'll make this a little bigger and easier to follow. Get this guy out of the way somewhere. We will very simply cross multiply our 3 here all the way over for our 3x minus 7, and our 5 all the way over for our x plus 3. We'll take that and go a nice green this time. 3, not to forget our parentheses, right, that we put there and we put here. 3 parentheses 3x minus 7, close the parenthesis, move that guy over a little, equals 5 parentheses x plus 3 close parentheses. And now none of us, I know, will forget to distribute our 3 there and our 5 here, so we end up with 9x minus 21 equals 5x plus 15. We will then subtract our 5x from both sides, keeping it with like terms. Cancels out over here. Over here we end up with 4x minus 21 equals 15. Move this guy up a little, have a little more room. We would then add our 21 to both sides. And again, 21's cancel out over here. We end up with 4x equals 36, dividing by 4, and we cancel the 4's. X equals 9. We'll take a look up here, back at our large proportion, and we have an x here that we need to substitute the 9 in for, and then we have an x over here. So we will very simply just rewrite those down here in step 4, where we are told in step 4 to find our similarity ratio. So let's see, we'll just move ourselves back over, rewrite those guys. Looks like we have 5 over 3 parentheses 9 minus 7, and that equals 3 over 9 plus 3. By substituting our 9 in, we will end up with 5 over, what's 3 times 9 is 27 minus 7 is 20, and that will ultimately equal 3 over 12. Looks like if we reduce those, we will end up with, let's see here, we reduce those, we end up with 1/4 over here and 1/4 over here, giving us similar ratios, ultimately making our similarity ratio 1/4.